Welcome to solving systems of linear equations with rational coefficients. This can mean either decimals or fractions to begin with in the system. And there are multiple ways to do this. So for the first system, we're going to look at all of the possibilities. And I highly recommend that when you are looking at systems that you analyze it to see which method would be the easiest. And then we'll solve a couple of systems. So this first one, 2/3 x minus 1/2 y equals 4, and 1/4 x plus 1/8 y equals -9. So I'm only going to talk about this briefly, but if you wanted to eliminate the x's right away and keep the fractions, depending on how good your fraction skills are, you can definitely do that. So in order to create a common denominator, don't forget we can always just multiply the other one by the opposite. So if we were going to eliminate x's right away without getting rid of the fractions, we would multiply e1 by 1/4. Let me just make sure you can see that. Yes, you can. So we'd multiply equation 1 by 1/4, and then we would multiply equation 2 by 2/3. And that would give us 2/12, which is 1/6. So that would give us 1/6 y, or sorry, 1/6 x, and then we could subtract, then we would subtract e1 minus e2. If we were going to eliminate the y's, let's see if I can just sneak it over so you can still see the y's. There we go. So what we could do is we could have them both have a coefficient of 1/8. So that means we would multiply e1 by 1/4. And then because we have a negative and a positive coefficient, we would add the 2. Now that's definitely not a common way that students do that, but I just wanted to point out that it doesn't matter how you do that. Then what I'm going to do is I'm just going to go over here so you can see, and I'm just going to discuss this while still looking at the system. So what we're going to do, and this is probably the most common way, is we're going to eliminate fractions. And we do that by multiplying by the lowest common denominator. So that's what we're going to do. And so we would multiply this by 6, right? And then we would multiply this by 8. So I'm just going to slide over here. And so 6 times equation 1, 8 times equation 2. And then what I'll do is I'll just do that for you. So I'm going to multiply that. So that's 12/3, which is 4x minus 3y equals 24. And then 2x plus y equals -72. Now it looks just like the systems that we've been dealing with, but in this case, you can decide whether you'd like to use elimination or substitution. So if we were going to eliminate the x's, I just want to make sure you can still see that system there. So if we're going to eliminate the x's, we would take 2 and we would multiply it by e2. And because they're the same sign, we would subtract the 2 to eliminate the x's. In order to eliminate the y's, we would multiply the second equation by 3. And then because we've got those opposite signs, we would add them. And then if we were going to assess this based on substitution, which variable would you eliminate? Well, we know that we always want to look for a coefficient of 1 or -1, which is this one right here. So we would isolate y in equation 2. So that, of course, is looking at all of the different possibilities, right? So you can see how I have these arrows over here. Once you eliminate fractions, then you would either decide to eliminate the x's or eliminate the y's or use substitution. Either method, of course, would be just fine. So we'll take a look at this first system and then we'll solve it. So what I'm going to do is the most common. I'm going to get rid of the fractions. So if I look here, I have 2 fractions here. My lowest common denominator would be 6. And my lowest common denominator here would be 12. So half of 6 is 3. Plus 4y equals 6. 1/4 of 12 is 3. And don't forget to multiply everything by that one. So now it's already set up. If you look at it, using substitution wouldn't make any sense because all my coefficients are different than 1 and -1. But I can use elimination right away, and I can eliminate either variable, right? So I can subtract the equations and eliminate x's, or I can add them and eliminate y's, and it doesn't matter. So I'm going to go with this. Now, if you're confident that you've manipulated these correctly, you can take this value and substitute it in here. Unfortunately, if you forget, for example, to multiply this by 6 and you substitute it, you'll have 2 incorrect values, and that can be frustrating. I always choose to substitute it into one of these originals because I know they're correct. Whoops. Equals 1. So got 3 plus 2/3 y equals -2. Running out of room. Multiply both sides by 3. And y equals, and now I have my 2 values. Can't forget my solution set. X coordinate, y coordinate, right? So this would not be a nice system to graph, but if you did graph them, they would meet at 6 and -3. And the last one, so I've got 1 decimal and 1 with fractions in it before we get to the word problems. So when I look at this system, I don't see any method that specifically jumps out at me. I think either method would be good. You could multiply this equation by 0.8 to eliminate your x's. You could multiply this equation by 1.2 to eliminate your y's. You could isolate y in equation 1 and substitute it into equation 2, or you could isolate x in equation 2 and substitute it into equation 1. So entirely up to you. I'm going to use substitution for this one just to mix it up a little. So I'm going to isolate y in equation 1 and make sure I take that expression and substitute it in here. Whoops. So rewriting that and putting that expression in. Oh, just barely fits. And I'm going to distribute. Now remember, this is 1. So 1 minus 0.96. Your calculator can handle that. Now, that might look like an incredibly large number, which it is for the ones that we've been doing, but don't forget, I'm not asking you to graph it because that wouldn't work. Nothing wrong with that. So we take that x value and we put it back into any equation, either equation. -52. And we are done. So -190. And just like I say when I've taught this, the other methods, what I would do on the unit exam is I would take those values, right, and then I would substitute them back in. So we've got our -190 and 155. Let me just confirm that. Yep. So there's our solution set. So I take 0.8 times -190 plus 155, and of course I'm hoping for that 3. I've got it. Now I do the other one, -190 plus 1.2 times 155, and we're hoping for that -4. That's how I know that my solution is correct. And that's the end.